I'll wait for another 5 minutes, then I will start. So we'll start with our first problem. I hope you have completed your assignments. This session would be having similar problems of your assignment. So I hope that you guys will be actively participating and solving along with me. So let me start with the first question. I'll give 2 to 3 minutes for you guys to read. I will also read the question out. So Nicotiana tabacum cells are cultured to high density for production of polysaccharide gum. The reactor uses a stirred-tank reactor containing initial 100-liter medium. So the maximum specific growth rate of the culture is it is 0.18 uh, day inverse, and the yield of the biomass from substrate is zero point 0.5 gram per gram. The concentration of growth limiting substrate in the medium is 3% weight per volume. The reactor is inoculated with 1.5 gram per liter cells and operated in batch until the substrate is virtually exhausted. So the medium flow is then started at a rate of uh, 40, 41 day inverse, and the fed batch operation occurs under quasi-steady state condition. So the question asked is, question A is estimate the batch culture time and the final biomass concentration, and the fed batch operation is carried out for 40 days, and what is the final mass of cells in the reactor. And the fermenter is available for 275 days per year with a downtime between runs of 24 hours. So how much plant cell biomass is produced annually? So this question is about plant cell bioprocessing, and this is very similar to your assignment problem. So let us start solving by writing down the given data. So our given data would be initial volume V naught is around V naught is around 100 liters. Mu max is 0.18 day inverse, and the yield of biomass y-axis is 0.5 grams per gram, and there is not the growth limiting substrate, which is weight per volume. 3% is 3 gram in 100 ml. If we convert it in terms of liter, it would be 30 grams per liter. This is This is our S naught. So what else is given? The reactor is inoculum. X naught is 1.5 grams per liter. That's all. So we'll start solving for the A, which is estimate the batch culture time and the final biomass concentration. So we have already solved a similar problem. From that we can solve this. So as you know, we have to calculate a batch culture time to achieve a substrate. Final substrate should be nil, means SF should be 0. So SF should be 0, and your batch culture time can be calculated as usual 1 by mu max ln of 1 plus excess by your initial cell concentration S naught minus SF. This would be mu max is 0.18 ln of 1 plus 0.5 divided by 1.5, 30 minus 0. Let's solve this. 0.35 divided into 30. So 0.5 into 30 divided by 1.5 is around 10. This would be coming around 5.55 plus 2.39 something, 13.27. Approximately we can take 13.3 days. So this is our batch time. In the question it is asked is approximately what it is asked. It is asked estimate the batch culture time and the final biomass concentration. So to calculate the final biomass, X is equal to X naught in power of mu max into batch time, which gives us X naught is how much? It's 1.5 gram per liter. So 1.5 e power of mu max is 0.18 into batch time is 13.3, which would be 0.18 into 9.6. Okay. Nine point 76. So it is 9.76 gram per liter.
I think I made a mistake, ma'am.
Yeah, yeah.
It's, I think, 16.43.
16.443, right?
Yeah,
Yes, yes.
I'm sorry.
It's
I'm
okay.
sorry.
That's okay. So if it is 16.43 grams, we have come to we solved the part A. It is we just found the final biomass concentration. So the next would be fed batch operation is carried out for 40 days. What is the final mass of cells in the reactor? Or the end of fed batch it is. So the mass of cells at the start of the fed batch operation will be equal to the final batch cell concentration, we can multiply it by the initial media volume to get our final mass of cells. I will write the formula down. X naught into SF into V. Here the V is our initial volume, which is 100 liters. So it would be 6.43 into 100 liter. This is gram per liter. 164. So this is our initial biomass concentration at the start of the fed batch, I guess. So the final mass after 40 days of fed batch culture can be determined, which we can use the previous formula which we have been using for calculating batch x naught plus yx initial substrate flow rate time for fed batch. So when your biomass is going for fed batch, it is already we have calculated here 1640 43 it is 43 grams plus our y-axis is 0.5 into 30 grams to 41 days. That is the flow rate given into 40. How much it is coming around?
24,616.42, ma'am.
Yeah, around 24,600 plus 1,640 it is coming, I guess. Okay, so we'll go to the next one, which is the fermenter is available for 275 days per year with a downtime between runs of 24 hours. How much plant cell biomass produced annually? So the reactor is available only for 275 days. So other days it is idle. So we have to calculate in that much uh, period how many runs we can make. So for that we will calculate followingly. So for calculating biomass produced per run, 2.62 kgs minus the volume, 151.5 into 100, 150. So 26240 it was 26240 minus 150 would be, so the total time for a reactor, the entire batch, fed batch, everything together would be batch time plus fed batch time plus downtime. So 13.3 days we calculated plus 40 days for fed batch and 1 day for downtime. If we do this, it would be 554.3 days. So they have already given 275 days only reactor is operational. So what we can do, we can divide 275 divided by the number of days taken for completing one run is 54.3. So if we do this, it would be around, I think around 5 point, what's it is? 5.064. So
5.06.
yes, sir. So approximately it is 5 runs. So as the reactor is only operational for 275 days, in that 275 days we can operate only 5 runs. So this would be the answer for that question.
And one doubt.
Yes, sir.
This 2.6, it is 26.2 kgs or 2.62 kgs?
Uh,
On,
Wait a minute. 1 minute, sir.
it will be 26, I
Yeah,
think,
yeah,
ma'am.
26 it would be.
Yeah,
Yeah,
sorry.
it is from gram to. Thank you, sir.
No, no, ma'am, please. I am also making mistakes.
So, so this is similar to your is this similar to your previous assignment problem or
A little bit different, I think.
a little bit I
Almost similar, I
yes,
think.
yes, because
It's similar.
yeah, the subject contains almost similar problems and there will be
Yeah,
little bit
yeah.
tricky questions inside, like we will miss that. So if this much run is only going to happen, so per year how much biomass we can
That is right, ma'am.
yes, so 5 into whatever biomass we have calculated. If we multiply that, we will get the amount of biomass we will be producing per year. Okay, so we'll go to the next question. I think this would be similar, very similar to your assignment question. So I'll give 2 minutes to read the question. So you can itself start solving the problem, I guess, because it is very similar to the assignment question.
Ma'am, in the earlier problem, someone had a doubt, I think, last time. They had put it in the question forum regarding the final um, biomass produced, I think.
Which question, sir? Assignment question?
Yes, in the assignment question. Just before this, when you can you just show me the first question, ma'am?
Oh, well. Yes, sir. How
How
much?
much?
Yeah, yeah, yeah.
Yes, yes.
So if we
How much
multiply,
plant?
yeah. So,
How much plant cell biomass is produced annually? I think one of the participants did not get the answer. Basically, he or she was not subtracting the initial biomass.
okay, okay,
So that is why he or she was not getting the answer, I think.
okay. So, they have posted it in the discussion forum, sir.
Yes, yeah, it's posted in the discussion forum.
Okay, okay.
So I think if we can, uh, that's right.
Yeah,
Thank you, ma'am.
yeah, it will. I will check the forum then.
Okay.
Yeah, I'll inform the concerned people so that they will be replying to it.
Yeah. The answers were right, but only thing was, I think she did not minus
Yeah,
the
initial.
initial substrate
Okay.
concentration.
So,
And the question number two.
yeah, question number two.
Sorry.
So, let's start writing the given things. So this is a fed batch mode with the intermittent addition of fructose solution to the culture medium. So as given, the initial volume at the quasi steady state is V naught is 3,300 liters, and the nutrient solution is at the flow rate of 100 liter per hour, and the fructose concentration in the feed solution, and okay, S naught is 400 grams per liter, X naught is 15 gram of dry weight per liter. We have to assume that Monod's kinetics and the yield coefficients are given. Mu max is zero point 0.2, Ks is 0.5 grams per liter, and the yield is 0.3 gram of dry weight per gram. So I have not given the full question. Okay, so this the same question. It has similar questions as the assignment question. So the first would be, I have forgotten to give that. The A would be to determine culture volume at quasi steady state when T is equal to 5, 5 hours. So this would be question A. I have forgotten to give it there. So if we want the culture volume at time T, this fed batch is already running. So our given at the time of 5 hours, what would be the volume? Culture volume is being asked. So to calculate that, V is equal to V naught plus Ft. So we know our V naught is 300 liter and F is also given already. T is 5 hours. So we can directly substitute 300 liters plus 100 liter per hour into 5 hours. 300 plus 100. Right? So 800 liters. So V is 800 liters means the culture volume at the quasi steady state when the time T is 5 hours is V is equal to 800 liters. So option B would be, plus we have to find the dilution rate. So the formula, as we know, dilution rate is F by V. F is already given 100 and V is 800. So it would be around 0.5 RMS. So option, the question number C is to determine the concentration of fructose, which is our substrate, at time t is equal to 5 hours at quasi steady state condition. So we know that under quasi steady state condition, D is approximately equivalent to mu. So it went again I have to write. So we have to determine concentration of fructose at T is equal to H at quasi steady state. So at quasi steady state, we know the dilution rate would be approximately equal to mu, and then the question is already given that it's following Monod's kinetics. So Monod's kinetics is mu is equal to mu max S divided by Ks plus S. So at quasi steady state it will be mu is equal to D is equal to mu max S divided by Ks plus S. And from this we can rearrange it to get the substrate on one side. Okay, dqs plus s equal to mu max is mu max is minus s equal to d into ks, which would be equal to mu. So it was in mu max we take all the s terms on one side. It finally will come to ks divided by mu minus b. So it will be s. So this is what we were looking into. So for that we will substitute all the values. D we found out, Ks is given 0.5, mu max is 0.2 to 0.125, we solve this, we will be able to get our substrate concentration, that is the concentration of fructose at time t, which is 5 hours at the quasi steady state condition. So what would be the answer? Would be around 0.83. Okay. So this would be the concentration of fructose at time t, which is 5 hours at quasi steady state. So the fourth of D would be determine total amount of cells. We need the mass of cells at quasi steady state. When T is equal to 5 hours. So the same formula which we were solving before for X, which is the biomass, total biomass. So at our quasi-steady-state condition, and when there is a high cell density, our substrate would be lesser than what we have already given. The input lesser than input would become due to as the cells have already started utilizing almost fully. So for quasi-steady state, we would be applying D is approximately equal to mu in the mass balance equation. When we apply that only, like I was solving before, the same formula, initial biomass at the time of 5 hours, your yield, substrate initial substrate, flow rate, and time for fed batch. So if we substitute things first, we will calculate x naught. T is x naught into V naught, which is what is our x naught is? Yeah, x naught is 15 grams of dry weight per liter, and our V naught is 300. Which is 4,500 grams. So let's substitute in this. X is equal to 4,500 plus our yield is 0.3 into substrate initial substrate concentration is how much? 400. This we can also write as S naught. 400 grams per liter into the flow rate is, and the time for fed batch is given as 5 hours. So if we do this, 1500 plus 1000 grams or 64.5 kg. Right, so this would be the total amount of cells at the quasi steady state condition when time is 5 hours. So if some other time period, as I think in the assignment question some other time period was mentioned. So similarly, the next option is to calculate concentration of cells. We have calculated the amount of cells, now we want concentration. At 5 hours. So what we have to do to get the calculation concentration, what we will be doing? Total biomass divided by our final, that is at time t, at time 5 hours, right? So the biomass we just calculated was 64.5 kgs, and the volume we had calculated previously, which is 800 liters. So how much it would be? That's around 80.625 gram, or we can calculate. Make sure to whatever conversion is being asked, whether it is gram per liter or kilogram per liter, you have to convert accordingly. Here it is gram per liter. I am keeping for uniformity sake, I am keeping it gram per liter. So the next subdivision is, if your QP is 0.05 grams of product per gram of cells, and P naught is 0.1 gram per liter, determine product concentration at time t. So we have to do the, I hope you remember the biomass product balance when it was initially discussed. So if we do that, it is P, the final P is product as P naught V naught divided by V plus QP into XM V naught divided by V plus dt divided by 2 into T. This we can replace right here. So I'm continuing that step here. P naught V naught divided by V plus QP XM V naught by V plus dt by 2T. We will write based on the whatever given it is there. We have the yield coefficient, yield of with respect to substrate and substrate inlet concentration. So based on that we will modify it and write V naught by V plus dt divided by 2 into T. So if it is just substitution, you can also do, you can substitute in this 0.1 gram. Initial is given as point, like P naught is 0.1, QP is 0.05. Substitute these in this. It's given, I have not given that in the questions. I just missed that question part. So it would be initial volume was 300 liter and the final volume is 800 liter. plus QP is given as 0.05, and instead of XM only we are substituting our yield, which is 0.3 into our inlet fructose, right, which would be 400 grams into V naught is 300 divided by 800 plus D is 0.125, right? Yeah, so 0.125 divided by into 5 is the time divided by 2. So let's solve this and get the answer. So D is the 20 point 20.6625. So 20.6625 grams per liter. So this is the product concentration in the vessel at the time T, which is 5 hours. If the initial product is assumed to be 0.1 gram per liter and the QP value was given as 0.05 gram of product per gram of cells in hour. So this would be for the question 2. I think we have only 2 more problems. They are all very similar. So this is the third question. Please go through it for 2 minutes. We will start in 2 minutes. So as you can see, this is like almost very similar because there is no much difference to this problem and the previous problem. So I think we can start by noting down the given values. So what would be the given? We have V naught. So let me read out the question. So penicillin is produced by Penicillium chrysogenum in a fed batch culture with the intermittent addition of glucose solution to the culture medium. So the initial culture volume at quasi steady state is V naught equal to 500 liter. Let us make a note of it. So the glucose containing nutrient solution is added with a flow rate is 50 liter per hour, and the glucose concentration of the feed solution and the initial cell concentration are given, which is S naught is 300 grams per liter and X naught is 20 grams per liter. So the kinetic and yield coefficients are also given. Mu max is 0.2 R inverse, Ks is zero point 0.5 gram per liter, Y-axis is zero point 0.3 gram of dry weight of cells per gram of glucose. So determine the culture volume at time t is equal to 10 hours. So initial volume is already given. In the previous problem we were asked the initial volume, right? So in this problem it is we have to calculate the culture volume at time t equal to 10 hours. So with same formula, which is V is equal to, let's start, V is equal to V naught plus Ft. Just uh, make sure to write the given data first and then start doing your calculation. Otherwise in the middle it will all look similar and it will get confused. So V is equal to V naught plus Ft. So we were asked V at 10 hours, right? So V naught is already given, which is 500 liter plus F is 50 liter per hour into 10 hours. Calculate 500 plus 500 is 1000 liter. So V is 1000 liter. Done. So what would be B, which is what it's asked. Determine the concentration of glucose at 10 hours at quasi steady state condition. So same concentration of glucose at quasi steady state condition means same way as we solved before. So first we have to find the dilution rate, which is F by V, which is 50 liter per hour divided by 1000 liters, 0.05 R inverse. So at quasi steady state, D is approximately equal to mu. So like last we solved, right? We'll get into this expression, right? From mu max S plus Ks plus S equal to D. Mu max is equal to dks plus ds. Is equal to dks divided by mu minus d. Okay, so from this only we got this as I explained previously. So just substitution. What is our d value? It is 0.05, right? And our ks value is given as, let me go back to the question. Ks value is 0.5. So 0.5 into 0.05 divided by mu max is 0.2. and d value again we have to minus in. So this will give us our S. So what would be the answer? So it is 0.16. So S is so this we have calculated 0.16 grams per liter. So what was the last one? Determine the concentration and total amount of cells at quasi steady state when T is equal to 10 hours. So same as before, how do we calculate the concentration and total amount? First we will calculate the amount. From there we will do the calculation for the concentration, right? So let's see. Xt is equal to x naught t plus f by x. You know, x naught we can write as initial into volume 500 liter plus f is 50 into 0.3. So 50 into 0.3 into 300 into 10, 45,000. So 55,000 grams or 5.5 kgs, right? So what would be the concentration? Our final volume, we did calculate our final volume. Due to some technical error, I have lost it. So we have calculated our final volume from this formula, which was 1000 liters. So for cell concentration at T is equal to 10 hours, it will be xt divided by E, which is 55,000 divided by 1000, 55 grams per liter. Is it right? So this question is also over. So all these three sums were very similar, so we were able to solve quickly. So I have the another only one question. I would give few minutes for you to uh, make a note of how we can start solving the problem. Let me go to the next question. So this is the question. Please read it for 2 to 3 minutes. So, in what way this this can be solved? Whether it looks similar to the previous problems or it has some other methods to be followed. Just read it once. Whatever idea you get, let me know. Then we can continue the session. Okay, we will start solving. So let me read out the question. A Clostridium strain is propagated in an essentially anaerobic condition. The culture produces a byproduct of energy metabolism. Um, so the system has the following characteristics. So they have given all our yield coefficient, Ks value, mu max, and maintenance coefficient, everything. And a stirred fermenter is operated in fed batch mode at quasi steady state with a feed flow rate of 4 meter cube per hour and feed substrate concentration 80 kilogram per meter cube. So after 6 hours, the liquid volume is 40 meter cube. So we have to calculate what is the initial culture volume. The same formula which we have used for the previous problems that we can use. And what is the concentration of substrate at the quasi steady state? That also we know. We have been solving that. And what is the concentration of cells at quasi steady state? Which is we have to calculate. And what mass of cells, which is X, is produced after 6 hours of fed batch operation. So in these two places only it will be different from the previous ones. So let's start writing down the given values. So given is already clearly given here. So we'll go to the okay. So we were asked for question A, initial volume were asked. So V is equal to V naught plus Ft. We don't know V naught. So V minus Ft, right? So if that is the case, 40 meter cube is the final volume and your flow rate is 4 meter cube per hour into 6 hours. So that would be 16 meter cube. So first part A we have solved. For part B, it is substrate concentration they have asked. For that we need to know our dilution rate. So F by V and our F is 4 divided by 40.1. R inverse. And as I derived previously, is can be found from dk divided by mu m minus t 0.1 0.15 kg per meter cube 0.35 R inverse minus 0.10 R inverse. So if we solve this, how much it is coming? Keep all the units in the same way uniformly maintained, otherwise it will lead to confusion later on. So here everything is in kg per meter cube and meter cube, so we will keep it as such as kg per meter cube. If it is specifically asked for you to convert it to gram per liter or something, you can convert it at the final step. So this answer would be 0.06. Okay. So coming to the tricky part. So what is the concentration of cells at quasi steady state? Means what is the value of x at quasi steady state? How can we start solving this? Because what always choose a formula based on whatever is given. If there are two unknowns, we cannot solve them easily. So whatever needed for our substrate balance is already there. So we will start using our substrate balance formula. So in case if we take the limiting substrate in the fed batch, that derivation, when how it starts, it is dx by dtx mu minus d. We can substitute s as s into v, right? So in case of quasi steady state, we have a this product is it is not directly coupled with energy metabolism, right? There is a byproduct only which is coupled with energy metabolism. So we will start with this. Instead of x, we will write substrate balance. We will write mass in minus mass out is 0 because it is fed batch. There is no generation also. I hope you remember from the derivation which was solved. We divide it on by v on both sides. We will be getting substrate. Okay. So assuming your QP is 0 here, it will become ds by dt is equal to d into si. F by v will become d. QP term will become 0. MS term alone will be there. So, so how further we can solve this? Any idea what we can do to make it a simplified form where we have all the known components of the system, and so that we can get the value of x? This is the one we have to calculate. So any idea?
Integrate, man.
Integrate that we can do, but for that we need time frame, right?
Yes.
So what I can tell. So basically it is a quasi steady state, so you can use ds by dt is equal to 0 and mu is approximately equal to d. If If that can be used, one part of the equation will become 0. So I think it will be easier to calculate for us then. We can keep x as an unknown in one side and start calculating. So that's why I'm telling to pay attention to the uh, words which are already given in the question. So from there we can pick up some things like this. So in case of quasi steady state, ds by dt is actually 0. So in that case, we can write, and also our substrate at the end will be lesser than the initial substrate concentration. So, and also mu is approximately equal to d. So if we do that, ds by dt will become 0, and this part will be dsi. This will become 0. This will be present, and instead of t, because we don't know mu, we know the mu max but not mu. So in case of steady state, at quasi steady state, mu is equal to d. So this can be also replaced. So if that is the case, dsa minus d divided by y-axis plus ms into x. So this is the one which we want. So what we can do, we can rearrange things. Now we can substitute. This will give us x, which is the concentration of cells at the quasi steady state. So let's start substituting. What is the value of d? D is 0.1, and substitute S naught value 80 kilogram per meter cube, and our y-axis is 0.23 and ms is 0.135. So substitute this. Calculate. So that will be 14.04 kilogram per meter cube. So this is also done. And find the concentration. And the last would be what mass of cell is produced after 6 hours of a batch operation. So whatever we found now is the concentration of cells at the quasi steady state condition. Now they have given us a time frame of 6 hours. So we know the volume after 6 hours is 40 meter cube, and we know the concentration of cells From this we can calculate the amount. This x into v. We know around 14.04 kilogram per meter cube of cells during quasi steady state, into final volume is 40 meter cube. That is the case. Would be around 561.6 kg of biomass. This is at end of fermentation, which is at the end of your fed batch. So what was the question again? What mass of cells is produced after 6 hours of fed batch operation? If your sorry, so sometimes what would happen is like you will leave the answer paper as is, thinking that this is at the end of fermentation only they have asked, so this much is only produced. But from the start it is being kept, right? So calculated, right? So you have to calculate how much at the start of it batch was there. Then you have to subtract, then that will give you the amount of biomass which is produced during the fed batch. So that is what is asked. So if we calculate, we have calculated the V naught value, right? Which is here. So we no, the total volume which is 16 meter cube. This is your final from where we have calculated. So based on that, at that time, at that volume, how much was the biomass? We have to calculate, which is the same formula here. X into V. X is 14.04 because that was the start of the quasi steady state into 16 meter cube. So if it is the case, it would be around 220. 4.64 kilogram. So to calculate mass of cells produced during your fed batch, if this comes into picture, you have to minus this, what happened at the end of your fed batch fermentation and what was that at the initial stage of fed batch fermentation. You have to subtract, minus would be around 336.04 kilogram. So this would be the mass of cells produced during the period of the fed batch. This is at the end of 6 hours. This is at time t is equal to 0, and during the process this much is the only one produced. So that's all. If you have any doubts you can ask. Yes, sir. You want me to put up all the questions
Yes,
there
ma'am.
in?
Yes, ma'am.
I've been sharing all these slides with the NPTEL team, but I don't know whether it is being
Uh,
shared or not.
I think they are sharing it.
They are sharing it,
Yes, yes, yes.
yeah, because I
Okay.
have been putting it up there.
It is coming up. It
Yeah,
is
and
coming up.
also I have uploaded the whatever session is happening, I'm uploading it in YouTube also, so that in case you have any doubts, you can go back and watch also.
Thank you, ma'am.
Yes, sir.
Thank you, ma'am.
Yes, sir. Thank you, sir. Sakshi, do you have any doubts?
No, ma'am.
Okay, thank you. So, if there are any other doubts, you can leave the meeting actually.
Thank you, ma'am.
So I'll solve this first question again. So if you guys were not there, if you have any questions, you can ask. So this is, I guess it is similar to your assignment question, but it is not the same. I hope you have submitted your assignment. Uh, Karthik, do you have any doubts in the problems? In any problem?
No, ma'am.
No.
Whether you have solved this problem today?
You have already solved it.
I didn't.
Sorry, I'm not able to hear you. Can you type what you're trying to talk?
Ma'am, can you hear me, ma'am?
Yes, yes.
Sorry, ma'am, I couldn't join by time. I saw now only.
Okay, okay, it's okay. It's okay. You will be
Okay, ma'am.
provided with a link to watch the how to solve the problems. So if you have any doubts in
Okay.
your when you are doing your assignment, you would have come across some doubts. No, you can ask that if you have any.
Uh, Not so doubts, ma'am. Since I solved the problem,
Okay,
I got.
okay.
Okay. If any doubts means, how can I contact you, ma'am?
You can send a mail to my. I will type my mail ID there.
Okay, ma'am. Okay.
Yeah, you can take the
Yes,
mail ID
ma'am.
and you can mail me.
Yes,
Or you can ask in the discussion forum stating that it is from the live session. Mention the date and time if possible. If
ma'am.
possible, alone date
Okay,
you
ma'am.
mention. I have given the mail ID down in the message inbox.
Okay, ma'am. Okay. Ah, if I had any doubts in between the session or within the curriculum, I will message you, ma'am.
Yes, yes, sure.
Uh,
You
uh,
can, so almost the session is already over. So if you want, you can also disconnect the call.
yes, ma'am.
Yes.
Thank you, ma'am.
Thank you for joining. We'll solve the first problem again once again. As there was a technical issue and all my annotations have gone. So 3% weight per volume. Sensitive is 3 grams per 100 ml. 3 gram in 100 ml, which we can run 30 gram in liter. Your time would be max ln of 1 plus x naught s naught minus sf. We know that sf is 0. So 1 by point. These are all given. Ln of 1 plus 0.5 to 30 equal 0.5. It should be given us around 15.3 days. So if that is the case, the biomass density at this time can be calculated using SF equal to x naught e power mu max into TB, which is 1.5 grams per liter e power of 0.8 to 13.8, which will give us around 15.4 grams per liter. So for part B, it is x naught equal to x of into V, which is 16.4 into 100 liter. X is equal to x naught plus 0.5 per gram. Yes. will be around 0.52. So this would be the end of the session. Thank you for joining.